there's more people now that know about the importance of wolves to ecosystems and the threatened nature of wolves in different parts of the world. There's more people that know about that now because we made direwolves than before we made direwolves.
Welcome back to Brave New World, the podcast from The Standard, where we explore the cutting edge of science, technology, and the future of humankind. I'm your host, Evgeny Lebedev. And in this series, we'll venture into the frontiers of neuroscience, longevity, consciousness, and the extraordinary breakthroughs reshaping our species. Today's guest is Ben Lamm, serial entrepreneur, technologist, and co-founder of Colossal Biosciences, the world's first de-extinction and species preservation company. Ben's mission is audacious: to use genetic engineering not just to conserve endangered species, but to bring extinct ones back to life. In this conversation, we'll explore the science, the ethics, and the imagination behind this new field. Ben Lamm, welcome to Brave New World.
Thank you so much for having me. Excited to chat.
So excited to talk to you because what you're doing really is Brave New World. And it's fucking cool. And I am super jealous in a good way. I'll explain to you why later. But without in any way trying to explain what you're doing, I'll hand over to you because I think you do a much better job.
Well, I'm excited to chat, and I'm excited to hear why you're jealous about it. That's even more exciting. But we at Colossal, we're the world's first de-extinction and species preservation company. So we're actively working to bring back extinct megafauna and keystone species from various time periods, leveraging genome engineering, computational biology, surrogacy, and even one day, hopefully, artificial wombs. And obviously, our flagship project is our woolly mammoth. We have about 40 people working on it. And yeah, it's going pretty well. We've built out about 175 scientists in the US and 60 in Australia. And we've got about 17 academic partners around the world that are all kind of coalescing on this mission to bring back extinct species and, hopefully, help conservation along the way.
So how does it actually work? Because it's not cloning. A lot of people have this idea that you're actually cloning the woolly mammoth or cloning the dire wolf, which we should talk about it later. But how does the process actually work?
I wish we were just cloning. That'd be amazing. In our lobby, which you've got to come see, we've got this giant, frozen looking mammoth that's 10 feet tall that we worked with Peter Jackson and others to design, because most people have this vision of, we've just found a perfect mammoth or a perfect dire wolf or a perfect dodo. We grab a cell and clone it like they did Dolly, and the end, right? And so they think it's cloning, but you can't clone from a non-living cell. And so I think of it more from a software engineering perspective as that we're rebuilding extinct species, leveraging computational analysis. So we look at ancient genomes, which are massively fragmented. For the woolly mammoth alone, we have about 104 genomes, ranging from about 3,000 years old all the way back to about 1.4 million years old. Many of them are from Russia and northern Siberia. And we spend a lot of time rebuilding the extinct species genomes. And then we have to map all of that data to the closest living relative. In the case of the mammoth, that's the Asian elephant, which is about 99.6% the same genetically. And then with that, we then identify all of the things that are fixed. And then you have to start editing using a lot of different technologies like CRISPR and others to actually change all of those different sequences that matter. So you don't have to change everything, but the core things that we identify that matter, you have to change all of those. And then you get to do the cloning step. So once you finally actually have all the editing done, then you get to do what they did with Dolly. It's called somatic cell nuclear transfer, where we take the nucleus of an egg, of a cell, and put it into that of an egg cell. And then you finally have an embryo that you can either implant in a surrogate species like an Asian elephant or other African elephant, or put into eventually an artificial womb. And so when people come to our lab, they see a lot of the lab side, and I think a lot of times they're shocked at how many women and men are on computers. There's a ton of computer analysis that goes into this, and a lot of it actually happens in conference rooms and on computers, not just in the lab.
So it's only, oh, I say only because I'm sure it's very complicated to bring that 0.4% to which elephant is the? I understand the Asian elephant is the one that's closest.
Asian's the closest, correct? Yeah. So we just try to focus on the things that really gave rise to those lost physical attributes or phenotypes that make them cold tolerant. So, and what's great about having so much genetic diversity between a million years of samples is we can really zero in on what are those fixed mutations. Because if you only have one sample or two samples, then sometimes it gets cloudy on what exactly truly drove kind of that species to have its unique characteristics. And so the more samples we get, and the more data we have, the more we can refine and refine and refine. People forget that like humans were building the pyramids while mammoths still roam the earth. And so sometimes people think they put them in the category of like dinosaurs, and they're like, oh, they're like 65 million years ago. It's like, no, we were here when they were here.
But for this project to work, you have to have a close living a species that's close to, so you couldn't bring back a dinosaur, for example.
There's no dino DNA. We get one of the questions we get every single day is about dino DNA. There is no dino DNA. I hate the word impossible. I just don't think there is dino DNA because DNA degrades at such a crazy fast rate that it's highly unlikely that we as humans will stumble on intact dino DNA. I think we could probably get some proteins from demineralization of bones, but that is such a far step from truly understanding the true genetic makeup of a dinosaur was.
And if you did, is there a living species that you could you could edit the genes of?
I mean, you'd start with a bird, right? We put $150 million into our avian genomics group to work on the dodo and then the South Island giant moa. I mean, I'd argue that a giant moa is about as close as we lived next to next to dinosaurs, right? It's 14 feet tall, and there were actually 9 species of moa, and these are a flightless bird. But unlike the dodo or like an ostrich, they don't even have a wing appendage. So they're literally just like a slender body, and their feathers were almost hair-like, and so they're covered from tip to tip in these like feathered hair kind of things that maybe some dinosaurs had, depending on where you fall in that argument about different dinosaurs having different levels of hair or feathers. And they were 13 feet tall. So they were pretty dinosaur-like. If you ever Google moa feet and you look at like the moa feet, you're like, oh, that looks like a T-Rex foot. It really does.
When did it become extinct?
The moas went extinct about 600 years ago through hunting.
So why is the woolly mammoth the flagship? I mean, I can kind of understand why, because it looks cool, but to explain.
And there are no like hate groups on, a lot of people have different feedback on different things in this world, but there's not like a lot of like a Facebook hate groups for mammoths. I think generally speaking, woolly mammoths are globally loved and adored, which is awesome, right? And it's one of those species that's like just out of human reach, right? Like I said earlier, many people think it was like a dinosaur. People categorize it in that, right? They see Ice Age, they see all these movies, and they're like, oh my gosh, it was right there. And so I don't know what it stirs in our imagination, but it stirs a lot of imagination, and I think it inspires a lot of people. But what's awesome about it is there's great samples from all over the world. It's universally loved. It's been well preserved in the permafrost, so we know what they look like. We don't have to just look at like skeletal morphologies and argue, was their hair color brown or was it purple or whatever, right? Like we actually know because we can see it, which is amazing. There's, as you probably know well, that the in northern Siberia, in northern Canada, in northern Alaska, and kind of the Arctic Circle, and in Circle Polar North, so it's a little bit larger than the Arctic Circle. There's tons of space, and there's an opportunity to help revitalize that ecosystem leveraging large cold-tolerant megafauna, with the mammoths obviously fall within. You could have a lineage of elephants that don't have human-elephant conflict because they are now existing in this other area. And then you have this halo effect outside of inspiration that all of the technologies that you're developing probably have a pretty direct application to elephant conservation, and elephants are pretty amazing. And so it's kind of like, okay, you get to inspire the next generation. You get to like create a lineage of elephants that hopefully won't go extinct again. So it's hard not to, not have the mammoth as the flagship. I mean, I'm not allowed to pick a favorite animal that we're working on or the species.
But mammoth kind of is.
But the mammoth's pretty awesome.
Yeah. And so what? I've done lots of elephant conservation in my time, and I'm still involved with it. I grew up in a family of scientists. My grandfather was a zoologist, biologist, so I grew up with animals, and I'll come to my story of why I'm jealous of what you're doing, but how does it help elephant conservation?
So interestingly enough, not a lot of these species are well researched. People typically in conservation are conserving land and trying to protect species that way, which is amazing. But we need new tools like assisted reproductive technologies like IVF in elephants. We need to create things like iPSCs, induced pluripotent stem cells. Think of like stem cells that you can differentiate into any different type of tissue. There's a terrible, terrible disease called EEHV. Mm-hmm. It's this endothelial herpes virus that kills 20% of elephants every year. It kills more than poaching, more than elephants that get killed from human-elephant conflict. EEHV is the #1 killer of elephants. And so if we don't want our mammoths to be susceptible to EEHV, it's kind of in our best interest to cure that, or at least play a role in that. And I'm very happy to say that, after a few years working with Dr. Paul Ling at the University of Baylor College of Medicine and working with a handful of zoos here in America, what we've done is we actually have a vaccine, an mRNA vaccine, that's actually conferring resistance to the most deadly strain of EEHV. So I think there's all these other things. Like we're doing a project right now in Botswana with elephant havens that rescues baby elephants, and and they're working to say, how do you build synthetic herds? How do we put elephant orphans together in social dynamics and put them back into the wild, which is important for us, right? Because we're going to be having to build synthetic herds. So all of that research helps existing elephants while it's also helping us. We've got a really cool project with Save the Elephants in Kenya, where we're using drones and AI to identify migratory patterns and also socialization along those migratory patterns, and how do different elephant families and groups work together with bigger herds of elephants in these migratory corridors. Well, once again, that's all crazy important for if you're going to ever rewild mammoths back into the wild while it's helping elephants. So it gives us this like cool opportunity to like fund elephant research with these incredible people that are working in the field with elephants, but are massively underfunded.
Ben, the reason why I'm jealous of what you're doing is because I had the same idea as you, but you actually did something about it. In 2020 during COVID, I read Yuval Harari's book, Homo Deus, and which was a cautionary tale about what we humans are doing or about to do. And one of the characters mentioned in it was George Church and his project to clone the woolly mammoth. So I reached out to George, and I heard him out, and I thought it was incredibly fascinating, and we talked about making some plans to do something, but then I got distracted and never actually did anything about it. And you did, and it's great. I'm very jealous in a very good way.
Well, look, we welcome advisors, partners, investors. So you can be as involved with us as like. This is a worldwide effort. This is a collaborative effort. And it was in the early stage of COVID. And I was running a defense company at the time that I started. And I got really sick. We started to have lockdowns in America. I locked down. And I thank God I'm now on the other side of it. I'm super healthy again. But I got super sick at the time. And it made me change a lot of the ways I was thinking. And at the time, I had built 5 software companies. And when you're locked down and you can't travel anymore, and you do, at least for me, I did a lot of introspection, and the results of that was do I want to keep building software? Is this my life? Like rinse and repeat software companies. And I just thought I couldn't do it anymore. So I brought in the CEO to replace me, running my defense software company. And he did a great job on the business and growing it and selling it. And I thought, the Mammoth will not see the light of day in an academic lab. And that's not against academia. It's just there's different time pressures, there's different needs. How you would have to have we've got 220 plus people, right? And so you have to build all this infrastructure, and unless you're going to give an academic lab, even if you gave an academic lab $5 billion, I don't see it happening in academia. I think it had to be taken into the private sector to be really pushed at the speed that we want that the private sector moves. So, I don't know. I think I'd be like you, and I'd been excited about it, maybe a little jealous about it if I wasn't working on it, if I wouldn't have gotten sick. But it made me, COVID in that season made me really do some hard soul searching about what was important to me.
Sometimes that's needed. Will you explain to our listeners, viewers, a little bit about George, who's one of the great geneticists, synthetic geneticists out there?
I would argue, and I'd love to get your perspective on this. I would argue George is the father of synthetic biology. I would argue that all of the next gen read-write technologies, of reading genomes, of being able to do DNA assembly on genomes, multiplex editing, meaning editing multiple parts of the genome at the same time and synthesizing pieces of the genome and delivering large cargo into cells. I mean, George, it's his vision that has really brought a lot of that to bear. And lots of people get credits along the way, but he was the first to ever leverage CRISPR and some of these technologies in a cell. He was the first to ever sequence yeast back in the day. Now I feel like we're now at the doorstep of being able to engineer life, do directed evolution and accelerated directed evolution in life, and change life around how we can work with it. Things like microbes to eat plastics or woolly mammoths or whatever. I think that we're in this season of synthetic biology combined with AI and compute that I truly think that George was the father of a lot of this.
Yeah, no, he's definitely a godfather of a lot of stuff, and that's going to be changing the world, already changing the world, which is exciting.
He's funny, he's charming, he's brilliant. It's hard not to just want to kind of like old biblical, I want to drop all things and follow George.
True, I can vouch for that. I did actually do one really cool thing. As I went to Chersky up in northeast of Russia, where the Zimov father and son, Sergei and Dmitry, are doing the permafrost project, which George was working with at the time.
I was supposed to, in the first years of our business, I was supposed to go, and we were working, collaborating with some of the Russian Academy of Sciences folks. I'd love to go up there to Yakutsk and to Chersky and to all of it.
It's just incredible lunar landscape, incredible nature, and these sort of completely untouched beaches where you if you don't walk fast enough, the mud sucks you in, but then you sort of find these incredible fossils.
So cool.
And during the dinner, we were just having some vodka and chatting with Sergei and Dmitry, and it turned out that my grandfather actually greenlit his project in the 80s when he was he was running the biology department at the Soviet Academy of Sciences, and he signed off his project. So I was very, very pleased to that he's left such a legacy.
Yeah, this project and ecosystem restoration, bringing back the mammoth. This is in your DNA. So, look, this is a lifetime journey we're on. Not just bringing back the mammoths, right? That'd be much shorter, but putting them back in the wild and everything. And I want flourishing. I see the Siberian tundra and the mammoth steppe flourishing again, where you have things like mammoths and woolly rhinos and all of it, right? And so that's the world that I see. And so, this is in your DNA. So we welcome you with full open arms to be as involved as you want to be.
Well, I'm looking forward to coming visiting. Will you please explain, Ben, what's the environmental impact of potentially having herds of woolly mammoths out there?
Yeah, so it depends on who you ask. If you can get the right density of herds and the right number of mammoths and then potentially other cold tolerant megafauna back into that, then you can have a significant reduction in in the potential of greenhouse gases coming from there, both not just carbon but also methane, because there's more methane and carbon stored in that region than anywhere else in the world. And if it melts, it's about twice as much that's currently in the atmosphere, and we don't want more. It's way more than cars. It's way more than anything else. It'd be terrible. And so what they found in Pleistocene Park with the Zimhoffs is that with the right removal of these trees, which elephants are great natural removers of trees, and they've done these studies in forest elephants in Gabon, where they actually only remove trees that are not helpful to the forest. Like it's amazing, like what nature knows on its own. And so so elephants are natural kind of like environmental modifiers. They also pack the landscape. So in different parts of Africa, even in the dirt, you actually have colder dirt in different places because of the packing of the migratory patterns and the night winds actually hitting that. Well, if you extrapolate that to the far north, you'll have that hopefully where you have packed very tight snow, so you don't have kind of this blanket effect of loose snow that kind of creates almost like a heating effect. You have that packed snow for migratory patterns, and then the cold winter air can actually get closer down to that layer of the top of the permafrost, and then it just gets colder and colder and colder. So then when you go into the summer months, you're always going to have that top layer that melts and produces grasses and produces that in the summer months, but it won't melt as far down because it's colder for longer and deeper, and it's a lower temperature that has to be raised. So there's been a lot of ecological modeling that's been done that says if you could get to the right density of mammoths or other species, then you could maintain everyone talks about the 1.5 degree tipping point for carbon, but you could maintain that. So that's one field of thought. There's another field of thought where you've got other people, and what I found is, the scientific community likes to argue, believe it or not.
I can believe it.
Yeah, we deal with that all the time. And but in that, we found others that say, well, we don't agree with that. It's like, but when you act, what's interesting though is when you sit them down, both sides agree that the loss of herbivores and seed spreaders like elephants, like rhinos, like others lead to ecosystem collapse and degradation. And everyone that we've talked to agree that it would increase the nitrogen oxygen cycling, they'd spread seeds, they'd defecate, they'd help the landscape, and that the landscape would be a more efficient landscape for carbon sequestration and also would flourish and more biodiversity would be there than without the animals that we're talking about. And so generally speaking, everyone agrees it's a really good thing to rewild them. It just depends. The level of positive impact is on some spectrum, and I don't think we'll actually know until we do it.
So when is it going to be done? The next decade? Before?
Hopefully sooner. So our goal. We're in the editing phase. So we've done a lot of the computational analysis. We've done the rebuilding of the genomes. We've built the reference genomes for Asian elephants, African elephants, and Borneo elephants. We've done all the comparative genomics. We've done deep studies on genetic diversity in the lineage in many samples of existing elephants that we have. So we've actually built this kind of pan-genome across mammoths and other elephants, so that we can kind of understand kind of all of the genetic diversity and what separates mammoth genes that are fixed versus just elephant genes. So all that work's done, and we've created induced pluripotent stem cells, so cells that we can differentiate into different types of mammoth cells, and we're in the editing phase. So we announced that we thought it was like 50-ish genes that we had to edit. We think it's now closer to about 85, and we've gone through the process and we're about halfway done. So halfway done in the editing of these cells. We continue to kind of refine our editing strategy, and there's a couple of areas of the genome we're in the process of synthesizing some very, very big blocks of DNA. And if all goes well, by the end of 2026, which is our current target, we will have mammoth embryos. And then we'll start trying to put them into elephants. And just so you know, one of the things we really believe in is parallel pathing. And so we have a whole animal operations team that's working with Dr. Thomas Hildebrandt, who runs the Northern White Rhino Project, on creating IVF protocols, in vitro fertilization protocols for elephants. So we're not waiting till we have embryos to then just go do it. We're actually in that process right now, which I think is really, really important. And so best case scenario, which we're pretty bullish, is by the end of 2028, we'll hopefully have our first calves. And even if that were to slip a little bit, we're not talking decades, we're talking months or years, right? It's really just going to be contingent on how many elephant access to elephants that we have. But yeah, I'm very, very bullish. And I think in the next few years, we'll have our first mammoth calves.
And so you've already had some successes, right? From the mouse, the woolly mouse, and
the dire wolf. Yeah, but the woolly mouse, I got to be honest, the woolly mouse was one that I was really excited about. We were excited about the woolly mouse for 3 reasons. Number one, internally, we were excited because one, it showed that the edits that we had already made in the mouse equivalent of the edits that we had already made in our Asian elephant cells were the correct ones, and they were conferring the resistance, conferring the traits that we wanted in terms of the hair density, the follicles, the colors, and the thickness, right? And so we were very hopeful that would work, and we knew when we saw them that it had worked. So number one, we were excited. The second thing we were excited about was that we did that project in 1 month, and so the end-to-end pipeline for our de-extinction work happened, and it worked within a month, which was incredible. And these were at the time the most genetically modified animals on the planet, leveraging precision editing. The third thing that we're really excited about was that they were all healthy. So our screening process and our sequencing at the various stages of editing and on the embryo level produced healthy animals. Mm-hmm. We didn't have any issues with the animals. The animal welfare was perfect. And so we were very, very happy with that. Now, what we didn't know is when we showed the world the woolly mice, it'd be on every late night talk show. It'd be on Saturday Night Live. It would be on the cover of magazines.
Are you sure you didn't know that?
No, we did. We thought, we made a joke. People, like, when we did a press release about it, people were like, what are their names? And we had taken 2 out of our colony to show to the world, and we just named them Chip and Dale to be funny. And it became like a thing. There was like Chip and Dale meme coins. Everyone was like losing their shit over it. It was crazy. So everyone was like super stoked about it. And I remember being at South by, and I was on stage, and they were asking about the woolly mice, and I couldn't get away from the woolly mice, and people had this like woolly mice fever, and I remember sitting there and saying, well, 3 weeks from now is going to be really interesting. As I was saying this in my head, I was like, if people are losing their shit over these mice, in 3 weeks, we're going to show the world the dire wolves that we have. So it's kind of weird. We're like showing the world these woolly mice, knowing that we've got 2 male and 1 female dire wolf running around. And I'm sitting there like, man, people are going to lose their minds. And sure enough, 3 weeks later, everyone lost their minds on our dire wolves. But it was cool. We took, we spent a lot of time, but to the point about the mice, the dire wolf project was only an 18-month project, which is insane. We have about 500 times more data than anyone's ever had on dire wolves. We were able to get 13 times a full read of the full genome of 2 different dire wolves that had 60,000 years of genetic divergence between them. So I can't tell you definitively. Like, people always ask me all the time, like, but do we know dire wolves are white? I was like, well, they're a Pleistocene wolf. What I can tell you is that these 2 dire wolves that are definitively dire wolves, that came from 2 different places in America with 60,000 years of genetic divergence, they were both white. Can I tell you every single dire wolf was white? No, because I can't statistically tell you that. But odds are they're highly likely that most of them were white or light colored. And so it was crazy. And so, like, when we launched the project and showed the world publicly, it's funny, because you talked about Peter Jackson earlier. I was sitting in Peter's living room in Wellington, New Zealand. And I was like, I got to show you something. So I hooked up my laptop with like a dongle up to his big TV, and I showed him that the it was just, I mean, this was internal. Like we didn't have this like produced. We just showed him that little howl of those first two dire wolves, and he lost his mind. And he's like, he got goosebumps, he got emotional. He's like, this is what you have to lead with. You have to show the world this. And then immediately he said, I'm really good friends with George R. R. Martin. We should call him. And I was like, that's a great idea. Why didn't, and I was kicking myself. I was like, why didn't we think of that? And so he introduced us to George R. R. Martin. George was crazy enough to take a call with me. I put him on Zoom, and I was like, we don't have an NDA. You don't know me, but you're friends with Peter Jackson. So I'm going to trust you. I'm going to show you something. And I showed him some videos that I don't know if we ever showed him publicly. We showed him some videos, and he's like, am I looking at, because he Googled us, he knew what we did. And he's like, am I looking, but he had no idea what he's on the call for. And he's like, am I seeing what I think I'm seeing? And I said, you are. And he just got emotional. He teared up, and he's like, I can't believe it. And I said, I want you to believe it. I want you to come see them in person. And we haven't let a lot of people do that. So we flew them out. We took them to a secure location. We brought them there, and he and his wife Paris got to hold them because they were still puppies at the time. And he's like, this is one of the best days of my life. I was like, well, you made these things famous for the world. And it was awesome. So that's one of the things that's cool, like kind of like your grandfather that really started and supported the Zimovs in kind of their quest for how do we revitalize the Siberian tundra, right? It's like you have these weird emotional moments. I'm sure like when you found that out, when and maybe even more so if you had a couple vodkas in you. But you have these emotional moments. Like what we're working on isn't just science and isn't just monetizable with technology and cool, but it is emotional. And so to watch this guy that is created, some of the biggest fan fiction in the world, right? That people like gravitate to sit there and like be overwhelmed, and to be able to do that for this guy that's got everything in the world. He's made a fortune. He's got fans everywhere. He's lived his dream, that he's got everything in the world. And to be able to show him that and be a part of that, it's cool. Yeah. It's a fun job.
Yeah, that's super cool. It is a fun job for sure. Who just explain to those who don't know who George is, who he is.
So George R. R. Martin wrote most famously a Song of Ice and Fire, and he wrote some other stuff, which became the HBO hit show Game of Thrones, which now they have House of Dragon. They've got another show coming out about knights or something, and whatnot. A lot of things. I don't have time anymore because of my job, travel, and I have a 15-month-old son, which takes up the sleep cycles in my brain. So I don't have time to play video games as much as I used to. But he also wrote Elden Ring, which is an awesome, crazy deep universe in RPG. And so he's one of those brilliant fantasy writers and creators that write such deep content in the world. It's like next level Tolkien in terms of like how you think about what he's able to write. And so one of the things that I would credit George R. R. Martin on is not just making direwolves like household names, but he made fantasy cool, right? Like you've got like moms and dad in Iowa in the United States that never played Dungeons and Dragons, probably weren't into all the stuff that you and I were into, that are like watching shows about wizards and dragons, right? And so I think he really helped make fantasy cool for the mainstream. That's
certainly true. And what was the reason for the woolly mouse? Was that a pilot project for the mammoth?
It's a great question. So on the woolly mouse, we wanted, you can really test if you're on the right way, kind of, three different ways plus the woolly mouse. You can do molecular tests and say, okay, did the edits work? Did you put them in the right place? Were there any off-target effects, meaning unintended consequences? You can screen for all that on like a molecular level, number one. Number two is a little creepy. but I'll tell you about it.
Go on.
You can actually, with induced pluripotent stem cells, so when we revert our elephant cells back into their naive state, that we can then differentiate into different tissue types. You can test the follicle density and test, like when you make the edits to see if these skin cells produce hair and produce the right type of hair. You can do that. That's kind of creepy. It's in a lab dish. It's a little weird. Like I mean, we think it's cool, but I don't know if everyone else would think it's cool. And then your third kind of area is like you birth a mammoth, right? Which is 22 months of gestation, lots of risk involved, right? And so a lot of times people will use in like healthcare things like mice models, pig models, and even things like non-human primates. So different types of monkeys to test different types of drugs. We don't do that, but we engineered the mouse equivalent of those same genes, because there's about 200 million years of genetic divergence between elephants and mice. So we didn't want to just like take a mammoth gene and like throw it in and kind of roll the dice. We spent time understanding the computational analysis to say, what is the mouse equivalent of that gene that we know does the exact same thing? And then we engineered those in. And so what was cool about it was when the mice were born, they were the color we expected. When their hair grew out a little bit further, it started to get that dense thickness there. And if you Google and look at pictures of like, the side by sides of our control mice versus our woolly mice, it's night and day, right? They look like, the craziest punk rock little mice you've ever seen. And it was cool because it showed that not only we were correct, it was a validator for our hair edits that we've already made in the mammoth, number one, but it was also a validator that our end-to-end process worked and could work really quickly, and a validator that the animals were all healthy, right? And so for us, it checked a lot of boxes, which was pretty cool.
It's interesting, isn't it, how you put a bit of hair on something and people suddenly think it's super super cute. It's like I sometimes look at a squirrel and think it's just a rat with a very furry tail.
Yeah, but if we made a woollier version of squirrel, people would lose their minds.
Yeah, absolutely. Even woollier, yeah.
Yeah, if we made them woollier and made their eyes a little bit bigger, so they have that like thing that kids love, like no one in the world would ever be able to shoot a squirrel again.
What was the story behind the dire wolf? When did it become extinct? Was the closest living species to it? What?
Yeah. So dire wolves went extinct. They're mostly a North American species, at least from what we found in the fossil records. They're about 20% bigger than wolves today, and based on the density of the bones, they were heavier, they were stockier, they had a little bit more muscle to them, right? But depending on what episode you watch of Game of Thrones, I think this is based on their 3D budgets, because sometimes they're like the size of cars, and other times they look like just a dog. Someone just threw a dog in the scene and it runs by, and they're like, oh, there was a dire wolf, right? And so I don't know if it was their budget, if they were budget constrained and they put all the money into the dragons versus the dire wolves, but they were but in truth, dire wolves went extinct about 12,500 years ago, and they were a Pleistocene wolf. They ended up being what we know from the fossil records is they're about 20%. They were a little bit stockier and about 20% bigger, and they had a larger craniofacial component due to the fact that they were 20% bigger. And so that's what we knew. And what we did, we started the project about 18 months before the first direwolves were born, and we resampled a tooth about 5 years before because of the excitement of Game of Thrones. Scientists, about 60 scientists came together and says, oh, we're going to build the direwolf genome. But most of the direwolf samples that people had are from the La Brea tar pits, and due to heat, and there's thousands there. And so, but due to heat and acidification from the acid, there's no real viable DNA that anyone's been able to recover yet. And so there was a tooth that was found in a cave that they got about 15% of the genome about 5 or 6 years ago. And in that, they didn't have all the data, and they wrote a paper. And of course, media, media very, very well. But the media said, oh, direwolf, love salacious headlines. The direwolves were closer related to jackals than they were wolves, and they actually weren't even wolves. So that got people up in a roar. But you put a couple of pieces of headlines out there, and people will just believe it. And so people believed that for a season, and because in the reality of that paper about 5 or 6 years ago, from that tooth, one of the two samples we used was actually was actually inconclusive. It said that dire wolves were pretty closely related to jackals, still closely related to wolves, but it was inconclusive. But some journalists jumped to this certain conclusion, which then kind of made our lives a little hellish because we had to explain to thousands of people online. Yes, we know what paper you're referring to. Yes, it's incorrect, but it was correct at the time. So what we did is we then we resampled that same tooth. We found a skull through a museum partnership that had been found in a riverbed, and those were the 60,000 years. One was about 73,000 years, and one was about 10,000, 12,000 years old. And what was interesting is we found that we got a full genome from the tooth using newer methods and newer technologies that we developed, and we did the same thing from the petrous bone, which is inner ear bone, on the big skull. And when we did all the comparative analysis, we actually found that phylogenetically, where we as humans like to put things on that tree of life, remember, that's not how nature works, but that's how we're very good as a species. We need to put things in boxes. Like we're like, this box goes here and this box goes here. That's how, but the universe is way more fluid than we want to give it credit for. And so what's interesting is we found that genetically, dire wolves were closer related to wolves, and we were thankful for that because we wanted to work with wolves even though they're go on and off the endangered list here in America. They're easier to work with than jackals. And so dire wolves are closest related to wolves, and we started editing from wolf cells.
And what kind of wolves are they close to?
They're the close, just your general gray wolf.
Because if you say the dire wolves that you've created the white, I thought maybe they're more related to an Arctic wolf.
Yeah, so all of those are like subvariants of wolf and subspecies of wolf. Once again, that's something that we as humans make up. There's about 30 different ways to classify a species, and most of them are contradictory to each other. And that's where people want to always argue about like the Mammoth Project or the Dodo Project or the Direwolf Project. But fundamentally, they're about the same relation to a Arctic wolf as they are to a gray wolf or a Mexican wolf. And so
I'm at my house in Italy now, and I have wolves here, so hopefully they might say hello later by giving us a howl, including one Arctic one. She's a beautiful white girl, Maya.
Well, that's the fun thing about that's the other. So here's the other crazy thing about Colossal, which I think is fun, is there's so many. So we have a lot of parents and kids and educators and scientists and people that are excited about us. You got a percentage of the public that love, like a large percentage, about 95% that love us, right? Of those media impressions. And you know this well. It's like you get 95% positive or neutral feedback. I mean, that's insane. And the fact that we have that level of sports nuts, but then you always have that 5%. And part of that 5% that doesn't like us, I'd say about 20 to 25% of the 5%, so like 1 or 2% of it are in the conspiracy world. Like when we launched the direwolves, they're like, we know that Ben flew to Alaska, and we think he kidnapped Arctic wolves and gave them steroids. I got like accused of that. I got accused of them all being CG and like until all like computer generated stuff that was all done through like Chat GPT. Like we heard the craziest stories. We got accused from China that the woolly mice were bioweapons. Just crazy. I mean, just the stuff that comes online is just amazing sometimes.
It's well, yeah. I mean,
but it's also fun. Like we look at that stuff, and we like some people are very, very serious about it, and we look at it and we think it's like the funniest things. And all the memes that came about the Mammoth Project or the Mouse Project and the Direwolf Project were crazy. And I hope that we, in addition to the flagship species we're working on, like Mammoth, I hope we have a couple other surprise and delight moments like the direwolf, because I think that got people pretty excited.
Well, the thing having fun with it is the only way to be. You can't take it seriously, otherwise you go crazy. What was,
Yeah.
well, how did what was the reason for the why direwolf? It should, not because was it because of Game of Thrones?
No, so I wish I could tell you, hey, we're super smart, and here's like the 17 checklist items that we go through when we work on a species. But we try to it's kind of a little bit more of a three-dimensional model, but we try to think about it in a couple of different ways. Like one, can you do it? Like, is it possible to even do it? Number one, right? Like, is it like I love the Stellar sea cow. It's awesome. It's like a whale-sized manatee. But there's nothing to they're when they're born, they're bigger than manatees. So until we get artificial wombs to work, which we're working on, and hopefully we'll be successful there, and
Hmm.
then scale it, there's no way that we can gestate a stellar sea cow until we get there. So one, can you do it? Two, should you do it? And then that should you do it kind of breaks down into a bunch of different things. Like we try to think about, is there ecological impacts, right? And so we know that restoring wolves and wolf conservation is very important to the ecosystem, number one. Two, is there an indigenous component to it, right? Are there people that care? Like in Mauritius, the Mauritian people, but they're not, none of them are native to the island. They were all settlers of the island. The Mauritian people today care about the dodo, but it didn't have like like the moa, it didn't have a, like how the moa has this deep connection spiritually.
Hmm.
We went around to a lot of the big tribes in the United States and talked to them before we launched the Direwolf Project. And many of them said that the great wolf in their mythology, which is this huge white wolf who's the biggest, most alpha wolf that their generations had seen, many of them told us, including and these are the leaders of these tribes, said that they believe the great wolf in their mythology and in their oral traditions was direwolves. And they are in the land where direwolves lives, right? And their people were. And so we did that. And then we thought, oh, we could also benefit, kind of like the EEHV vaccine for elephants. We thought that we could develop technologies to help wolf and wolf conservation. So we thought that was cool. And then I don't know if every project will have this, but the Game of Thrones was kind of the extra credit, right? So it's kind of the Direwolf project checked all of the major boxes that we think about. And then we thought, oh my gosh, what an awesome way to bring people that care about like fantasy, and because direwolves are also in like deeper stuff like Magic the Gathering and World of Warcraft, and they're in a lot of this fantasy stuff, not just in the most popular modernized stuff like Game of Thrones. And we thought, oh my gosh, this is a huge opportunity to have a conversation with hardcore fantasy lovers and bring them into science and talk about wolf conservation.
Hmm.
Like there's more people now that know about the importance of wolves to ecosystems and the threatened nature of wolves in different parts of the world. There's more people that know about that now because we made direwolves than before we made direwolves. And I think that's awesome. And so the pop culture element of it, like I'm wearing a direwolf T-shirt that we
It's
designed.
cool.
That's absolutely. We'll send you some. We'll send you a
I
bunch.
thought
We'll
I
send
thought it
you.
was a heavy metal band T-shirt or something
Yeah,
like that.
yeah, it's
But
great. It's great. So I mean, so we've leaned into it, right? We've gone pretty hard on it, and so yeah, I think that the Game of Thrones wasn't it was definitely additive. Like we weren't oblivious to it. It was definitely additive, and we try at our core mission for the company is to create value, to create impact, and create inspiration. Some kid that's watching Game of Thrones with their parents sees this, or some teenager sees this, and they get excited about science. Then I think we made a lot of really good decisions.
yeah, well, it certainly ticks all the boxes. What about there's a lot of rewilding projects that go wrong
Yeah.
with wolves, but in particular. How does that work with the dire wolf?
So we have two males and one female, and they're on a 2,000-acre secure,
Okay.
expansive
Hmm.
ecological reserve. We have 10 people. So we are not rewilding this generation,
Hmm.
right? We always talk about rewilding as a part of our strategy, both for ecological, for carbon credits, for all these different components, right? But fundamentally, that's not 100% up to us. It involves governments, indigenous people groups, private landowners, public at large. So a lot of people have to opine on that side of things. And so I do see a world and sometimes it's controversial, where dire wolves exist in even larger, expansive ecological preserves on some of our indigenous partners' land because they have a spiritual component to it. I don't ever see us putting dire wolves back in like Yellowstone National Park and having them compete in that ecosystem.
Hmm.
George Church, though, I will, we got to bring it back to George because he's got big, crazy ideas. We're not doing, I want to preface this with we're not doing this. But I just want to, I got to pay homage to George. So we're not, I got to make this clear to your listeners. We are not doing this. But George will tell you if you look statistically at the impact that wolves have had on Yellowstone, it's been very good. But Yellowstone overbred bison, and while the wolves have brought balance back to um, the elk populations and the migratory patterns of deer and elk, they have not brought balance back to the bison. And Yellowstone culls about 700 to 1,000 bison a year. George will tell you in those valleys we should put dire wolves because he has said that to me and maybe on a couple interviews. But we are not doing that. But that is something that we kind of laugh about at times.
Well, we'll make sure we'll keep that in. The caveat about not doing it. But you talked about fascination with the dire wolf and it being one of the reasons why it's such an amazing calling card. But one of the animals that particularly I was fascinated with when I was a little boy, and I know my daughter Masha, who's 5, is fascinated by, is the saber-toothed tiger. What's the idea there? Is there if there is one?
So we are not
Even if they are can be quite scary to me.
Everything. I mean, people say that about like wolves, and people, if we were to work on, we're not currently working on saber-tooth tigers, but if we ended up working on them in the future, and I mean, who knows, we could, but we're not currently working on it. What's interesting is that people are like, oh, we'd be scared if you ever did something like a saber-tooth tiger, and the dire wolves are kind of scary because they're wolves. I'm like, elephants kill more people a year than wolves do by a factor of like 1,000, right? Like I'm more scared of seeing an elephant in the wild than a wolf in the wild.
Or buffalo, even more scary than an elephant.
Or buffalo, yeah. People are dumb and taking like selfies and getting gored in Yellowstone, right? And so there's 2 predominant saber-tooth tiger species. There was one called Homotherium, which they found in Russia, and they found in a lot of different locations. And they did have a longer tooth structure. And then the one that I think we always think about, but Homotherium is amazing. It was a saber-toothed cat. And then there's a second one that I think a lot of people think about is called Smilodon, which has even the more exaggerated. When we think about saber-toothed cats, I think most people think about Smilodons and not Homotherium. We've got great genomes for Homotherium. Some of our partners like Lou Vidal and others have sequenced. A couple of years ago, they found 2 cubs in the permafrost that were siblings, and they had great DNA from them, which is amazing. So there's great DNA for saber-tooth or for a saber-tooth cat that is Homotherium. There's not a lot of really great DNA yet for Smilodon. There's been some caves. There's been some promise out of like, I think that if you were to ever find really good DNA from Smilodon, it'd probably come from Patagonia because they were down there and they were at the kind of at the transition between the late Pleistocene and early Holocene. There were the climates were preserved that I think you could get good DNA from there, but nothing to date for Smilodon has really generated great DNA.
Well, if you ever do, you can definitely release it on my land.
I love that. See? Partners.
Yeah. Well, now I'll put myself for a minute into the 5% of people who don't like you and ask you a question. What makes you think you can meddle with nature?
Well, I think we meddle with nature every day, right? It's like, we overfish the oceans, we cut down forests, like half the species we're working on were killed by man. Like we murdered the thylacines. We like the Australian government put a bounty on the thylacine and paid people to murder them. Like that's a fact. Like that's why they're extinct. They weren't extinct because of sheep. They were extinct because we killed them. Same thing with the dodo, right? We killed them, we ate them, we introduced invasive species that ate their eggs and eradicated their future generations. And many people will argue this controversy here, but what you can see is that the rise of early man on different continents and the rise of early man and the fall of giant megafauna is directly inversely related. Every time you have humans that we know of at least, enter into a island structure or a new landmass, you see a massive decline in megafauna. You just do, right? We saw that in the old West in America when we went west and killed every bison we could, right, just for sport. And so I do think that I think we as a human species have meddled a lot with nature. And our goal is because, not only doing the de-extinction work, but all those technologies we open source for conservation, we're hopeful that we're kind of like a free R&D lab, like that's doing research and development for free for the world, for conservation. And so I like to say that, if you don't love what we're doing, this is just one thing. You should do something. The choice to do nothing is still a choice. And I think we've made a lot of choices to not do nothing with nature. I think we've made a lot of choices that have been pretty negative on nature. And now we need to use technology and innovation to supercharge our efforts to save it.
Well, we as human species, we really have messed up our planet in many ways beyond just exterminating the megafauna. And we've also done lots of great things, but certainly have done a lot of damage. And what are the ethical and moral considerations of the future of this project?
So I think that it's really important that we do everything. We try to spend a lot of time on being transparent and being collaborative and letting people in as much as we can. Number one. So I think that has to continue. We're certified by Global Humane and American Humane, the oldest animal rights organization here in the U.S. And I think that's important that we continue to maintain that. I think it's also really important from an ethical perspective that we draw certain lines. Like Colossal does not work on anything in the non-human primate world or in the human world. We get asked probably once a month if we're going to make Neanderthals. We're not going to do that, right? And so we've drawn some ethical lines about what we won't do and what we will do. And then, every time we work on a species, we want to go get cultural buy-in and collaborative buy-in. So it's not just Colossal in a vacuum making a decision to go like we did with the moa, right? We didn't just say, hey, let's just go get the moa and make the moa because it's like the coolest, biggest thing closest to a dinosaur. Let's just go do that. We did not do that, right? Like we worked with the government. We worked with Peter Jackson. We worked with Canterbury Museum and the leading moa researcher down there, Paul Schofield. And then we spent numerous trips working with the Naitahu people and the Maori people to get their blessing, right? So I think that is our hope is that we're not going to do everything right, but I hope we do a lot more right than we do wrong. And I hope that the way we do things is as important to me as the things that we're actually just doing.
And why not the Neanderthal?
Well, so we draw a line. I just told you we had to draw some ethical lines.
No, but why?
Right?
Why?
I think that once, I'm a pretty spiritual person and I look at human consciousness and I don't know where and how and all that evolved and changed. And so I think it's better, we have people that call us saying, well, you did the woolly mice, you're doing mammoths. Can you just apply mammoth hair to my hair? And I'm like, no, we're not going to do that kind of stuff.
that would make you lots of money.
I know, but it's a slippery slope, right? And so it's like, the more I already told you about the crazy conspiracy theories that a small subset of the population has about us. And so I just don't think that I think we have to draw some lines. And I think things like the Neanderthal and human evolution and even non-human primates, even because, there was a species, I don't think there's any DNA for it. So I think I could probably like cop out by saying that, kind of like dinosaurs. But there was a giant ape species called Gigantopithecus, which I think they've only found samples in China, but I don't think any of them were I think it was like six. I don't remember how old it is, but it's not. It hasn't produced any viable DNA. But there was a giant ape. We're not going to do that either, right? And so we just have to draw some ethical lines. You know, I'm sure somewhere, sometime, somewhere, someone will make it Neanderthal. It just won't be us.
Well, maybe you already have in China.
Yeah,
Who
who
knows?
knows, right?
Yeah, who knows what they're doing? So what can you imagine colossal technology doing next for beyond extinct species for humanity?
I think there'll be a couple things that come from this, right? I think that the spinouts of these technologies, like we will never use artificial wombs for humans at Colossal, but I think that there's technologies in that could help human fertilization, human IVF, and even allow for growing babies fully ex utero. We won't do that, but we'll spin that technology out and let people that have different governance structures, different things go do that. So I think there's a lot of applications to the genome engineering and the reproductive health technologies that we're developing. First, that will have positive impacts on society. It will be licensed out and not done here. I also think that if we can get our biovaults off the ground, or backing up existing species, our enhanced cloning protocols and cryopreservation protocols, and eventually artificial wombs, at least for a couple of core species groups or animal clades, then I would love for Colossal to become the production arm for endangered species, so that when you've got 100 Spix macaws left, well, how about we create genetically modified chickens that are laying edited primordial germ cells from Spix macaws, and instead of having the Tyson's food in Oklahoma, that's just chickens having a bunch of eggs for consumption, we have a similar production model using chickens, but then they're laying endangered species parrots that then you work with Brazil and others to rewild back into the wild. So I really do think that the technologies that we're developing at scale could productionize endangered species and save the planet. I mean, I know that sounds crazy altruistic, but I truly do believe that. Not all species, but maybe the top 50 keystone species.
Do you have any other species in your sights now?
I mean, I told you I'd love to do the stellar sea cow. That's that for me, because I think it's a foray into marine mammals, right? And we're losing whale populations, we're losing polar bear populations, we're losing a lot of animals that are classified in that marine mammal category. And there's just not enough research and money going into it. So I would love to work on an extinct marine mammal project, because I think it would be a big door opener to helping a lot of those species.
Yeah, a bit exciting new chapter. What are the pioneers in the new era of biotech and conservation that you admire?
So one of them, obviously outside of George, we've actually been selfish and collected a lot of them. I think David Liu and some of the work that he's done at Harvard in terms of how he has really kind of opened the door to base and prime editing on a single nucleotide editing level, which I think is really, really interesting. I think one of the most prolific minds in that category, who is doing more and more in longevity, and actually is more in the investor space, is Bob Nelson from Arch Ventures. Bob, if you don't know Bob, I would argue is the #1 biotech investor of all time. He's invested in 40 plus decacorns. Proud to say that we're one of them, but he's truly amazing, and I think that he has found ways to bring capital and innovation into really hard science that no one else has done at his scale. And so those are just some of the folks, but I feel like we are at this doorstep of synthetic biology where you're having people from all walks of life investing in longevity. Longevity 10 years ago was super, it had stigmas around it and whatnot. People felt like it was all snake oil. You now have real venture and real private equity and big family offices putting real capital into some of these treatments and whatnot that are providing incredible benefits to not just lifespan, but health span. and how we age. And so I think we're in a really interesting time in this category.
Yeah. What are the projects that he's investing in?
So he's done a lot of stuff. So one of his biggest claim to fame was all the CAR T therapies around cancer and cancer identification, cancer markers. He's doing a lot of work and investing in a lot of things around epigenetic reprogramming of cells. So how do we reprogram our cells? So because if you look at like cancer rates and if you look at a lot of things in the earlier cells, like in our 20s and whatnot, even though cancer does happen there and mutations do happen there, it is less than in your 70s. And so there's all of these things around kind of like how we do, reversing the aging of cells at a cellular level. Mitochondrial health, which are like the energy production systems of our cells, is also critical. So he's doing all of that stuff.
Well, as you say, it's a really, really exciting time between what you're doing, all the projects in AI and longevity. It's
I think that convergence is going to be just weirder and cooler.
Yeah. Super exciting. Funnily enough, the other person that was in Yuval Harari's book, who I also reached out to at the time, was Aubrey de Grey, who I also had on this show, and what he's doing is
and he had that whole issue that happened to him on the personal side, but he is a genius in that category, and he was early in that category. He was the one that was really pushing all the telomere stuff and the mitochondrial stuff, and I mean he is a lot of his ideas were just massively ahead of their time too.
Yeah.
Really smart guy.
Definitely very smart. Is there any questions that you feel I haven't asked you?
I mean, we've covered the gamut. I mean, this is pretty great. I mean, I'm thankful for you taking so much of your time in this podcast. This is awesome.
No, Ben. I find it, as I told you, it's a fascinating subject, and I'm very, very excited to come out and visit you.
I can't wait. Seriously, let me know. I'm having my second kid in the next 3 weeks, but after that, anytime after that, you're more than welcome.
Well, congratulations, Mr. Ben Lamm. It was a great pleasure to have you on Brave New World.
Thank you so much for having me.
Thank you, Ben. That was really cool. Really enjoyed that.
It is absolutely extraordinary, and you can tell that I'm awe-inspired and blown away by what these guys are doing, because in the dream world, that's exactly what I've been doing myself. And what gives me hope is that behind the showmanship of the mammoths and dire wolves, Colossal is also quietly working on things like elephant vaccines and genetic rescue for the northern white rhino. So this kind of technology can not just be used to amaze the world, but it's also protecting the world we live in.